to edify myself with respect to my electronic throttle system. So this is a drawing for the SX4, of course. This is the assembly that I have on the bench here, and of course the engine control module is what provides the drive. Well, I've got my PWM driver box here. Basically just applies a duty cycle or a PWM signal as an output. Now you can see here that the driver in the engine control module is actually an H-bridge affair, which means it actually applies the positive, it applies the polarity to both sides of the motor here for drive and retraction of the throttle. Now this is spring loaded. I can only, because of my arrangement here, I'm only driving it on the positive side, and it's actually not being powered to the closed position, which is what the car actually does for safety reasons, but it's just the spring bias that is actually closing it to the closed position, right? So some time ago I actually done I think a couple of videos on this over the years, guys, and I had my scope out. And I remember thinking it was kind of weird that the pulses would be wide and then they would narrow up to hold the position. And now it becomes kind of obvious to me why it does that. So just at 1000 hertz fixed frequency, I only picked that frequency because it seems to be the tone emanating from the assembly is roughly what you get in the car. I don't know what the actual drive frequency is. I suppose I could find it in the manual somewhere if I dug deep enough, or looked at the reference drawings and then worked the period back for the frequency, but it doesn't matter. This is close enough. But at 22% here, I can basically open the throttle to wide open, and again, if I turn the power off, it just goes back under the spring bias, right? So what we have here to hold it in that wide open throttle position again is a frequency of 1000 hertz at 14 volts being duty cycled or pulse width modulated at 22%, a duty cycle at 22%, right? And that actually, look at the rate that the throttle actually opens. You see that? See the rate that what the throttle opens? Now I can get that to open much, much quicker if I up the duty cycle here at 30%. You can see it actually affects the rate of the throttle opening, the duty cycle that is actually on the signal here. To overcome the inertia of this, it takes wider pulses. But once it's in that position, a narrower pulse will actually hold it, and that's exactly what the ECM actually does. Okay, again, I'm only powering this open. It's returning on just the bias spring, guys. Of course, it's safety sprung loaded to the closed position, but the car itself actually drives it to the back position. What are the other pins for? If we look at the pinout here, you can see that the other pins, we have 2-channel position sensing, of course, right? One is a common here. This one pin here. Position, and supply. Yeah, that's what it is. And again, the other two, these two are for the drive, and it is toggled for open, which is in this configuration now, and it toggles to drive it close, because the spring could break, right? That's a possibility, I suppose, although it's probably double springed, but it is driven back in the interest of safety. Just talking about an accelerator pedal command to the system, but of course there's the ECM itself actually controls functions like, you know, the minimum idle opening that it would actually open to, and then if there was any additional load applied, like the air conditioning was turned on, or the power steering pressure switch was sensing low pressure, would bump the idle to do so, it'll open the throttle. And of course you can also get interventions from the electronic stability program, regardless of your pedal input. The electronic stability program senses might be a good idea to close the throttle because of the lack of control status of the car. It's just, of course, going to override whatever your pedal input actually is. So it's not just a matter of gas pedal input that's controlling it. There's multiple subsystems which are overseeing the throttle position. Of course, the whole point to the electronic throttle. Idle flare, minimum idle, idle bump for air conditioning. Again, electronic stability program, cruise control operations. There's a number of things this thing actually does. That's it, boys. Cheers.